This question, f of x is equal to greatest integer function of x square minus x plus mod of minus x plus greatest integer function of x, the whole mod. Okay, so you have such a question, you can redefine this function. Let's write this g of x, which is x square minus x with the greatest integer, and a h of x, which is a mod of minus x plus greatest integer function of x. And you're going to check continuity at 0 and 1 as per the question, so you're going to approach 0 from the left, which is less than 0. Given example is minus 1 by 4. Let's say you can write this greatest integer function as x into x minus 1, and therefore it's minus 1 by 4 into minus 1 by 4 minus 1. So it's minus 1 by 4, and so it will be a positive fraction number because it's minus 1 by 4 to minus 1 by 4 minus 1. Both of them will be a negative and negative and negative. Oh, it will be a negative and negative, so it will become positive decimal number, and possible decimal number obviously will have 0 as the answer. So therefore when x is less than 0, this function itself is becoming 0. Okay, and the example that we gave is 1 by 4. So the next is, so therefore it's x into x minus 1. Let's continue. When x is greater than 0, let's give a positive value. Half and half minus 1 will give you a negative fractional number whose greatest integer will be minus 1. And similarly, when x is what about an x is equal to 0? We could have included that. So when x is equal to 0, the answer will be 0. And when x is greater than 0, the answer gets to minus 1. When x is less than 1, it will be same as greater than 0. So we can just have a common answer when x is lying between 0 and 1. And when x is equal to 1, it will be 0. When x is greater than 1, it's 3 by 2 into 3 by 2 minus 1, which is 3 by 2 into 1 by 2, which is 3 by 4, again a decimal number whose answer gets to 0. So these are your conclusions for when it's greatest integer, you can give values like this, very easy. But in other equations, only the greatest integer you can give value, the rest of it has to remain as x. For example, when x is less than 0 here, it is a minus 1 by 4 as an example. A greatest integer function of it is minus 1. So it will be mod of minus x minus 1, which will be x plus 1. So thus you have to redefine like that. So next condition is when x is equal to 0, this will be 0. When x is lying between 0 and 1, this will be the greatest integer part will be half, which will get to 0. So the answer is minus x, which will mod of minus x is plus x. And when x is equal to 1, it's minus x plus 1. And within the mod, so it can write it as x minus 1 minus x. Mod of minus x plus 1 can be written as x minus 1. When x is greater than 1, this will get to 1. So it's when x is equal to 1, it's x can be substituted as 1, and 1 minus 1 becomes a 0. And when x is greater than 1, as I told you, it's mod of minus x plus 1, which will be also x minus 1 when you take the mod. So x minus 1. These are the ways you have to redefine h of x. Now it's g of x plus h of x is what is f of x. So let's add everything. So the first one is x plus 1 when x is less than 0. First equation, second equation's limits can be at 0 when x is equal to 0. X minus 1 when x is lying between 0 and 1. 0 when x is equal to 1. And x minus 1 when x is greater than 0. Okay, the third one, okay, let's check the answer of redefining. Here it is. So let's see if whatever we have written is correct. X minus 1, x minus 1, f of, yeah, perfect. Thus you redefine the f of x. Okay, whenever they give you such a big question with combinations of functions, take all the functions and redefine, especially addition of functions. Okay, so now you have to check for continuity. You see at continuity at 0, to the left side of 0, it's x plus 1. Okay, and in h okay, you have to check only f of x. Okay, to the left side of 0 it's x plus 1, to the right side of 0 it's x minus 1. So x plus 1 will never be equal to x minus 1 at x is equal to 0. Therefore it is discontinuous at x is equal to 0. Discontinuous. So let's look at 1. To the left side of 1, to the left lesser than 1, the answer is x minus 1, and at 1 the answer is 0, and therefore lesser than 1 the answer is x minus 1. Greater than 1, this has to be greater than 1. Greater than 1 also the answer is x minus 1. Why is it at 1 we are getting it as 0? Okay, but that's fine, it's 0. This is the left hand limit, which is lesser than 1, and this is greater than 1, and at the end of the day it is for extending to 1. So when you put extending to 1, it will 1 minus 1 0, right hand limit also 1 minus 1 0 is equal to 0. Therefore it is continuous at x is equal to 1. So that's about the sum. Okay, it involves redefining. I hope you understood. So let me scroll up and see if I have left any sum. Did I do the sum? Let me do the sum. So this is like you have an f of x which is an x plus 1 when x is less than 0. What's the question though? Here it is. F of x is equal to x plus 1, x is less than 0. A mod of x plus 1 when x is greater than or equal to 0. And a g of x is equal to x plus 1 when x is less than 0. And a 1 when x is greater than or equal to 0. You have to find g of f of x. Okay, g of f of x. So g of f of x is nothing but g of, what is f of x for the first function is x plus 1, and you put it in g for less than 0, it will become x plus 2, but it's no more x is less than 0 because the limits is going to change. I'm going to teach you how. Okay, one second. Let's justify how the limits are going to change. Let's take f of x. Okay, it's x plus 1. So take y is equal to x plus 1, plot this graph. When x is 0, y is 1, x is 1, y becomes 2, and x is minus 1, y becomes 0, and this is the graph that you're plotting. And let me plot the g of x. When x is it is g of f of x. Okay, so then both of them are the same graph with respect to this and this, but g of f of x, which means when x is 0, y is 1, and g of f of x is g of 1, which will be 1 plus 1, 2. So when you are started with a 0 and you end up getting 2, so then the entire graph, can you see, is getting shifted. At 0 it's getting 2, and at 1, when x is 1, g of 2 will get to g of 2 will get to 3, and so it will be here, and so the entire graph is getting moved by 1 unit. Can you see here? It's getting shifted to the left hand side by 1 unit. Okay, so what initially it was less than 0, now it will be less than minus 1. Okay, for when initially the limit was since it's shifted, so it has to be less than minus 1. I hope you understood. So then therefore g of f of x, when you're defining, you can't write x is less than 0, write x is less than minus 1, and in that case it will become x plus 2. Okay, and for the second function, it will be g of f of x, which is g of mod of x plus 1, and mod of when you whatever is the value of x is greater than 0, obviously the answer will just be 1. So that is what is g of gof. Okay, which is again here it will be x is greater than or equal to minus 1. So thus you have redefined gof. Okay, now you can plot this graph. What is the question? Like you have to check it's continuous. Okay, at after minus 1. Okay, so how is this? At minus 2 it gets to 0, the x plus 2. At 1 it becomes at minus 1 it gets to plus 1. So the graph is linear till here. After this is just a constant, so none of these points is differentiable. So at the question is, at 1 is it differentiable at x is equal to 1? No. So then it's just not differentiable, it's continuous. Complete graph is continuous. This option number A is the right answer. So that this page is over. Let's go to next question. Next page. How do I go to next page? How do I go to next page? Yeah, I can do the sums where this question is if alpha is greater than beta is greater than 0 or the roots of the equation ax square plus bx plus 1, okay, is equal to 0. Okay, then they have asked you limit of x tends to 1 by alpha 1 minus cos x square plus bx plus a by 2 into 1 minus alpha x the whole square whole to the power 1 by 2. The moment I see compare this and this, how do I get this equation from this equation? Okay, by only considering x as 1 by x, which means the roots for the new equation that you are writing will be 1 by alpha and 1 by beta will be the roots. So then when you divide that, you write x as 1 by x will become a by x square plus b by x plus 1 is equal to 0. So it will become a plus bx plus x square is equal to 0. So thus you get this. So you understand that the roots of the equation are therefore 1 by alpha and 1 by beta for this equation which is given within the cos value. Okay, which is given the bracket. So let's continue the sum. Limit of x tends to 1 by alpha 1 minus cos x is 2 sine square x square plus bx plus a 2 sine square x by 2 by 2 into 1 minus alpha x the whole square the whole to the power 1 by 2. Now 2 and 2 get cancelled, root and square get cancelled. So limit x tends to 1 by alpha, you get a sine x square plus bx plus a, and you can write it as with the roots x minus 1 by alpha into x minus 1 by beta by 2, and the root and square has got cancelled. 1 minus alpha into x, where I can take the alpha out and I'll get 1 by alpha minus x. And if I take a negative sign out, I can write the 1 by alpha minus x as x minus 1 by alpha, so that I get sine theta by theta format. But what is missing? I don't have an x minus 1 by beta, so multiply and divide by x minus 1 by beta. I do not have this 2, so multiply and divide by 2 in the denominator. So then therefore can you see from here sin theta by theta format, limit theta tends to 0 is 1. But here x is tending to 1 by infinity doesn't mean, that just means 0 by 0 format, so it's okay. So so then therefore minus 1 by 2 alpha into x minus 1 by beta, limit x tends to 1 by alpha, direct substitution 1 by 2 alpha into 1 by alpha minus 1 by beta, whose limits itself is 1 by k into 1 by beta minus 1 by alpha. Taking the negative sign inside, 1 by 2 alpha is equal to 1 by beta minus 1 by alpha is equal to 1 by k into 1 by beta minus 1 by alpha. This and this get cancelled, k is equal to 2 alpha. That's your solution. So that whatever option, that is D, option number D. So let's go to next question. The next question is a limit of x tends to 0 1 minus cos square 3x by a cos cube 4x into a sine cube 4x by a log of 2x plus 1 the whole to the power 5 to the base e. Okay, so then the moment I see this and this, I know it's tan cube, so I can consolidate. So then 1 minus cos square is sine square 3x and a tan cube 4x by log of 2x plus 1 the base e whole to the power 5. So limit x tends to 0. And you can multiply and divide sine square 3x by a 9x square into 9x square, a tan cube 4x by 64x cube into 64x cube. So this becomes 1, this becomes 1 because limit x tends to 0 is 1. By apart from that, you also have the denominator remaining. Now it's 9 into 64 into x to the power 5 by log of, let's switch this as 1 plus 2x to the power 5. It's like 1 plus 2x the whole to the power 5. So you can multiply and divide it by 1 plus 2x. So 2x the whole to the power 5. So multiplying, dividing it by 2x the whole to the power 5 in the denominator. this becomes 1, log of 1 plus x by x format, correct? Considering that whole to the power 5, you can cut this and write it as whole thing to the power 5. So log of 1 plus x by x is limit x tends to 0 is 1. So this becomes 1. X to the power 5 and the x to the power 5 and the numerator is going to get cancelled. 9 into 64 by 2, 2 so 4, 4 to 16, 32. 32 and so the answer is 18. So option number B is the right answer. Let me check if the answer is right. Yeah, right. Let's go to next question. The next question is here, which is let a1, a2, a3 be positive consecutive arithmetic progression. Okay, so limit of n tends to infinity, root of d by n into 1 by root of a1 plus root of a2 plus 1 by root of a2 plus root of a3 plus dot 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 1 by root of an minus 1 plus root of an. So you're going to solve this. Okay, so the moment you're going to solve it, limit n tends to infinity, root of d by n. Let's rationalize this. You'll get a1, root of a1 minus root of a2 by a1 minus a2, a1 plus no, a1 minus a2, a1 minus a2 plus root of a2 minus root of a3 by a2 minus a3 plus dot 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 root of an minus 1 minus root of an by an minus 1 minus an. Can you see this is common difference, but it's a2 minus a1 minus a2, so minus d. So then you can write it as minus d. So root of d by n into minus 1 by d. So that's the LCM, and you're left with root of a1 minus root of a2 plus root of a2 minus root of a3 plus dot dot root of an minus 1 minus root of an. So a2, a2, a3, a3 and all get cancelled. You'll be left with the first term and the last term. So root of d and root d, or normal d will get cancelled. You'll get minus 1 by root n into root d. And you'll have root of a1 minus root of an minus 1. And you have a negative sign, you can switch that, and so root d into root of an minus 1 minus root of a1. And now limit n tends to infinity is this. Okay, so then what is sorry, an root of a1 minus root of an. Sorry guys, okay, because everything will get cancelled here. So root of an is nothing but 1 by root n into root d into root of an is a plus n minus 1 into d minus a1 plus root of a1. So then you have it like this, and you can bring the root n inside, so you will get a a1 by n plus n minus 1 by n into d, which is 1 minus d by n. So it will have a 1 minus d by n minus root of a1 by n. The advantage is 1 by n is going to tend to n is going to tend to infinity, so 1 by n will tend to 0, and so then you have a 1 by root d outside. So you have 1 by root d outside, and this 1 by root d outside, and yeah, so I have this has become 0, and so I have 1 by root d to be the answer. Let me check my answer. So answer has to be 1, so somewhere some mistake I've done. Let's see. Rationalizing, writing it as common difference minus d, and you have root of a1 minus, which can be switched, a1 plus n minus 1 into d. So when you bring the n inside the root, a1 by n minus n by n minus d by n where did I miss a d? Was there a d which was already existing? No. Root d by n, rationalizing, cancelling off. um, and root of n into root of d. Okay, let me cross verify with the answer. What is the mistake I've done? Yeah, I understood what's the mistake. This d will still, there'll be a d here. I missed the d here. It's nd by n, so it's d minus d by n. Okay, so that's my mistake. So I hope you understood. Root d and root d, this get cancelled, so answer will be 1. Hope you can forward this and correct it. So let's go to next question. So next question is sorry. Limit of root of 3x plus 1 plus root of 3x minus 1 the whole to the power 6 plus root of 3x plus 1 minus root of 3x minus 1 the whole to the power 6 by an x plus root of x square minus 1 whole to the power 6 plus x minus root of x square minus 1 whole to the power 6 into x cube. Okay, so let's do this. Limit of, can we do one thing? Can we just divide this by root x? So it's root of 3 plus 1 by x plus root of 3 plus minus 1 by x, this the whole to the power 6, and similarly root of 3 plus 1 by x minus 3 minus 1 by x the whole to the power 6. And let's keep the denominator as it is. Let's not do anything with the denominator as it. And now if you see limit x tends to infinity, and what have you done? You've just divided every term by root x, so you should also multiply by root x. But actually it's not root x, there's whole to the power 6 is there. So x to the power 3 by x to the power 1 by 2 whole to the power 6 is like x cube, which means I'm multiplying and dividing by an x cube. So this x to the power 3 is going to become x to the power 6. So now 1 by x itself is 0. And so then limit of x tends to infinity is root 3 plus root 3. Root 3 plus root 3 itself is 2 root 3. 2 root 3 the whole to the power 6. And this will be root 3 minus root 3. So this is going to become 0 by you have an x to the power 6 and x plus root of x square minus 1. You bring this x to the power 6 down and write it as x the whole to the power 6 so that you can split it up. Similarly, plus x plus root x minus root of x square minus 1 by x the whole to the power 6. Okay, so then the advantages, you can split this up further. So 2 2s are 4, 4 2s are 8, 8 to 16, 32, 64. So 64 and a root 3, root 3, root 3, root 3, root 3, root 3. How many root 3s are? So this is 3, 3, 3, 27. By what do you get here? I'm not sure, we can check the answer again, but this is the procedure to do the sum. Then split it up, you get a 1 plus root of 1 minus 1 by x the whole to the power 6 plus 1 minus root of 1 minus 1 by x the whole to the power 6. X tends to infinity may make it 0, and this term will itself become 0. 64 into 27 by root 1 is 1, and so by 2, so this will become 32, and such an answer does not is not there. Some mistake I have done somewhere. Let's check the answer. Yeah, you have 2 root 3 whole to the power 6 by you have 2 to the power 6. Oh, that's all. Okay, so then that is the answer is 3 root 3 to the power 3. Answer is 27. So hope you understood, everything is perfect. So let's go to next question. Wait, how to go to next question? So let me continue the next questions in the next video. It's becoming a very lengthy video.